right. So this is the embedded electronics course and digital signal processing part of it. Okay, this is not quite integrated learning as you have probably in some other courses, meaning that there are 3 different topics, and this digital signal processing is quite separate from the other topics, unless, well, although there are some, say, the interfaces in between, of course. So digital signal processing, what it's all about. It's about code, how to handle data. And you also in this course, we have the FPGA, right? Some, yeah, programmable logic design. Actually, quite a lot of digital signal processing is, eventually it's implemented in those FPGA circuits. That's probably the fastest way of processing data. Well, almost the fastest way of processing data. And then you also have embedded systems programming. Good. And that, yes, there are some answers on this part for say performance, calculation performance questions on the embedded systems programming. So this is a lot to do with the efficiency, how to make these calculations fast enough. Although we are now concentrating only on the sampled digital signals, only sampled digital signals. Okay, but anyway, so my name is Antti Piironen. My headquarters is in Leppävaara, so I'm a ICT teacher, and there I'm actually the one of those smart systems engineering teachers. The other name for the smart systems is embedded systems, meaning the hardware-software interface. I have a couple of favorite topics. I see one brave student from my sensors and interfaces course. Okay, and then, well, digital signal processing, and then, well, anything which is basically right at the software, the first software which touches the hardware on that level. That's my thing. That's what I do. Okay. And this classroom is quite warm. So, I think everyone already found my webpage. If you didn't, there is a link to this one on the OMA workspace for the course. There are the tools. Click on the tools, you will find it. Other way of finding my courses is actually you type sites.google.com/metropolia.fi/AnttiKP. There is always the list of my current courses. Or the sites Metropolia, not sites Metropolia, sites google.com Metropolia FI, and then that code, all small letters. Good. So that's where you find this part. Everything about this digital signal processing part of the course will be found from this page, nowhere else. Link is broken. How come? Very strange. Does it work? It's broken only for you. How does it go? The help desk, the survival guide, how to fix the problem, reboot the browser first, then reboot the computer. Okay, since this is actually done with the Google Docs, so you might actually consider using Chrome. Oh, yeah, good. So I'm using Google just for the sake that everything what I have here actually is Creative Commons licensed. So no secrets in here. So unless if you are going to make some money out of my work, you better consult me first. I guarantee I have better lawyers than you do. Okay. So don't make any money, but otherwise you can use it as you please. If you are using it as a part of your own stuff, just mention my name, we are okay. Good. So basically about this course. So after completion of this course, you should be aware of the say fundamentals of digital signal processing, and basically it means that you are familiar with most common operations and understand the importance of sampling operation and this key characteristic applied to digital filters. And basically we are going through some exercises, topical exercises, 5 of them in total. In ICT, I have 2 more exercises, but for this, you will get also some of that stuff on the embedded systems programming part. And also the other stuff I hope you have in some control theory on some classes. So you are actually already should be aware of those. So I'm not bugging you about those minor details like control theory. Okay. Anyway, so how to actually this part works. Last year I tried a really bold experiment called flipped classroom. How many of you are aware of flipped classroom method? None. Good. So it basically means that this time we are here is reserved for mostly interaction, questions and answers. And well, at the beginning, I also have the lab tutorial. Everything is also on video streams. Video streams and video recordings. I keep the same course in ICT degree program, and also I give, say, parts of this course as a, well, something happened to my, I lost power on my display. Good. So, yes, that's better. So I actually have something like 3 or 4 of these sets already. And I'm quite confident about my video presentations. So basically they are quite good, although very low budget production. For example, if we go to the signals part, which is our today's topic, we can find there's a video recording of my latest lecture right there. It's about signal fundamentals. Let's just for fun. So there's also audio, but it seems that these are not on. I'm not turning it on. So I'm going through the slideshow on my lecture. So my recommendation for you, before coming into this class, you will go and take a look at the video at the same time as you browse through this lecture notes, slideshow. It takes a couple of hours, something like that. Then we will have these exercises. Okay, I didn't remove the latest exercise tutorial, so if you are in a mood and a lot of time in hand, someone already told me that has a lot of time in hand, what you can do is also take a look at the MATLAB tutorials on internet and just go through the exercise by yourself. It's totally doable. Last year, I didn't have even this weekly sets here only this video material and everything there on internet, and say 90% of the students got this part done with flying colors, and the rest of them actually got the course done in any case, since this counts only 50 points out of 150. So without any points from the digital signal processing part, you can still pass the course. On the other hand, you can kiss goodbye the, say, your studies, further studies in master's program, since this is 15 credits and total, and you will get in maximum, say, 3 grade. You'll put quite a lot of weight on your GPA. It hurts your GPA if you miss this part. So take it seriously. And also another thing why you should take it seriously, well, you just need to know this one to call yourself electronics engineers or automotive engineers. Okay. So there are exercises also as videos. I will be doing these weekly sets of the tutorials also every Monday morning. But if you are sleeping on Monday morning, you can, wake up and, eat your cereals and look at the video or my stream. Next week, I might actually have a little bit better stream. Right now, if you take a look at the stream there, it's not that great since this camera is just pointing this way, and it's still there, but I'm not too happy about it. In addition to those videos, I also have things like MATLAB command history files, which shows every command what I made last time. There. So basically what you can do is try those commands yourself, and they also include some errors. Okay, you might also watch the video to find which command didn't work and why. But anyways, that's there. All right, so MATLAB command history file, another video. Usually I have only one video on tutorial, but for some reason I had a break in the middle of this first exercise. But anyways, the most important thing then, okay, there are 5 exercises, only like exercise 1, and then there's a template. That's a Google document, very simple Google document. And at this moment, you actually should be logged into your Google account using Metropolia Google account. So organizational Google account given you by Metropolia. If you don't know how to get that one, take a look at the, let's see, there's a wiki of help desk, IT services wiki. It has everything how to actually activate your organizational Google account. I hope everyone has it already. Have you? Is there anyone who hasn't yet activated the Google account provided by Metropolia? Yes, you should do it now. It just takes a couple of minutes. But well, for the first exercise, it's also okay to use your personal Google account. Is there anyone who doesn't have even the personal Google account? Okay, good. Some students are actually boycotting the Google. And then they are not boycotting Microsoft. I don't get it. Okay. But anyway, so for the first exercise, it's okay also to use your personal. But the second exercise, I start, subtracting some points by not using the Metropolia Google account. All right. So But anyways, when you get this page, this is just a template. What you need to do on the beginning is to make your own copy. So make a copy somewhere on your own folder and click OK. Then you can work on it. Don't try to work on my template. It doesn't work. I think you can make comments on my template, and that's because I want you to, if you find an error somewhere, you just point out as a comment, and at some point I'll go and fix it. But this, well, there can be some mistakes, since every time I have a new implementation, I go and do some editing of these files just for fun. And if you find any obvious error, you just point out with for example, wow, and add a comment. Good. But anyway, this is quite self-explanatory. So basically, I have some questions. Each exercise has 10 questions. And then there's also the write your answers on this column. And there is even a hint what I'm expecting. Write the comments, write the comments, write the comments. Then there's the insert the figure here. So sometimes I want some graphics. Read all the lines, since sometimes I want comments and also some text there, or some figure and some text there. So read the basically that column too. Good. Oops. Good. So that's the exercise. Then when you have done the exercise, or you think it's ready, basically what you will do, well, you will save this stuff on your Google Drive and then click share. Okay, and basically go directly to the advanced and click that one. So it's link sharing. On anyone with the link can comment. There. This is the feedback channel. So when you have done the exercise, you basically put it on your own Google Drive, wherever there, and then share it so that anyone with the link can comment it. When I get that link, I open it, and then I will comment. That's what I'm paid for, you know. I call it teaching. Good. Wonderful thing. You know. All right, so there we have link to share. Copy that. And basically paste that one to return form. Let me open the return form. So that's what the return form looks like. Okay, as you see, this is a Google form, just a standard form. Email address is required because sometimes that's the only way I can tell who actually submitted the link. And there's absolutely no names. Names, yes, for obvious reasons, add your names. You don't know how many times I get nameless returns on those exercises. Okay, then the which exercise number, that basically just is there to simplify the returns. or actually my work. Don't worry about those 6 and 7. They are there for historical reasons. I might actually take them away. But anyways, link to answers, that's the important part. When you put there that link to answers and click submit, then I'll get everything on one single file that I can start going through and give you some points. And of course, you may also click this one, send me a copy of my responses. It's a nice thing that basically just proves that you have given the answers in time. Okay. So that's how the things actually are going, and I'm just guessing that most of that is also in here. Since this is the first exercise time, I probably should also go through the general stuff. I have a couple of good slides here, not many, just a couple. Okay. Yeah, about everything. The DSP theory, what I have here, is only a brief summary. It doesn't replace any textbook. So, but anyways, there are a couple of good textbooks. This is my personal favorite, is Sanjit K. Mitra, Digital Signal Processing, already done on 2001. But still, you know, digital signal processing the theory hasn't changed that much. It's like, you know, electronics, the fundamentals are still there on the start of the, well, mid of the last century. Okay, but then there's also nice dspguide.com on online. Just read the copyright notice before using, but yes, it is free to use for educational purposes, and it has all the theory what you really need. And then warning about this other stuff. You can find illegal copies of this book on internet. Do not use them. You're stealing from that nice professor who actually wrote the book. You are practically stealing. Okay, now you have been warned. Motivation. This is a hot topic. Why I'm doing this? It's practically useful, yes. Mandatory, yes. Well, if you want to be an engineer. Only if you want to be an engineer. Okay, interesting. Yes, well, this is my personal feeling. I found digital signal processing being very interesting topic when I was studying, but on the other hand, I was studying when the DSP was very, well, it became a popular because of there was, for example, these graphic cards were still made in Finland, and that stuff, everything was new. So I'm an old dinosaur, so to speak. But the Tyrannosaurus Rex type, so don't mess up with me. Okay. So what you should know before entering the class? Okay. Fundamentals, functions, complex numbers, so basic math basically. Statistics, how to integrate and derivate, and then about some polynomials. Not too heavy actually in the math part. We are just using some of those as tools, and there's a lot of repetition of the mathematical tools what we are using. So, for example, on the ICT degree program, we also have a review of complex numbers. A math teacher is giving at the same time, but I think you already have had the complex numbers. In electronics, you just must know them. Something special then, well, series, Fourier transform, Z transform. But, well, you can actually do the course without a deep understanding what they actually mean. Okay, and those are the system topics. You will find them and enjoy. Yes, excellent. Another thing on the general, I also have a list of frequently appearing mistakes. The easiest way of avoiding making, costly mistakes is to check this list first and make sure that you haven't repeated the same errors than about 500 students before you. Okay, good. Assessment, each exercise is 10 points, total 50, and the whole course has 150 in total, so this is 1/3 of that part. And again, there's a frequently appearing mistakes, the figure type, just to make sure. Scoreboard. We will have exactly the same sheet for scoreboard together with Janne. So Janne is teaching this the embedded systems programming and the FPGA or programmable logic part of this class. So we will be actually publishing the scoreboard during the second week, maybe. I think that it will be published that time. Okay, good. So any questions this far about completion of this course? So fundamentally, everything is on the internet, including the last time labs implementation, the tutorials. When you come here, you should actually first take the video of the lectures along with the slideshow. Okay, you can even go and take a look at the lab tutorial. What I'm giving here is quite quick look at what kind of things there are on MATLAB so that you can survive these exercises. Okay, and then there's that template, exercise template. Make a copy of that, and then based on that, well, do whatever is needed to fill in the good answers there. By the way, before anyone asks, how many students can be on a group? Well, actually 3. Maybe I should edit that one already. But anyways, 3 is the maximum number of students in one single group. If there are 4, then make it 2 groups divided, so divide it into 2 groups. Good. All right. Yep. I think I will stop recording.